Hello. In this video, we'll explore Slurm, a powerful workload manager commonly used for machine learning and high-performance computing tasks. We'll learn how to run Slurm on Google Cloud using Google Compute Engine instances. This will be a hands-on demonstration using the Google Cloud Console so you can follow along easily. Let's begin by going to our Google Cloud page and creating a new project. We'll name it Slurm Demonstration. Google has a convenient built-in tutorial for setting up Slurm. If we search for Slurm in the search bar, we can find an interactive tutorial specifically for deploying a Slurm cluster. Since this is a brand new project, we need to enable several APIs. Typically, we would go to each required service and enable them individually. Alternatively, we could navigate to the APIs and Services page, search for the necessary services, and enable them there. For example, we need to enable the Filestore API. But here's a helpful shortcut. Since we're using the interactive tutorial, we can simply click the Enable APIs button, which automates this process for us. While the APIs are being enabled, let's discuss some of the storage services we'll be using. First, Filestore, which provides managed network-based file storage, essentially a network-attached storage or NFS system. Our Slurm cluster will use this for certain storage needs. Second, Cloud Storage, which offers object-based storage, a different storage model which comes in handy for some configurations and scripts. So we'll be using two different storage paradigms, both connected to our Compute Engine instances, which will use these storage services. Now that all the APIs are enabled, let's click Next and activate the Cloud Shell. This tool is very convenient for working with your infrastructure because it comes pre-authenticated with your user credentials. As long as there aren't special organizational policies blocking it, our Compute Engine service account should be ready to go with the editor role already assigned. To verify this, we can check the Service Accounts page in our project. Next, we'll clone the Cluster Toolkit, an open source system from Google Cloud. This toolkit makes it easy to spin up resources like Slurm clusters for AI, ML, and high-performance computing workloads. If we look at the GitHub repository, we notice that Terraform is used for the underlying provisioning process with a blueprint sitting on top of it. This toolkit essentially wraps around the Terraform code, handling many of the technical details for us. Let's proceed with the commands. After cloning the repository, we'll navigate into it. Next, we need to build the tool itself using the make system. Uh-oh, there seems to be an issue with insufficient space on this machine. Let's clear some memory and try again. Great, now our build is successful. Let's test it by running our G-cluster binary. When we check this file, we can see it's a Linux executable, and running the version command gives us a successful output. This confirms that we built using the main GitHub branch. We can also view information about its origins and the underlying Terraform version. Moving along, let's discuss our cluster blueprint. As mentioned earlier, the blueprint wraps Terraform for us. It sits on top of our infrastructure as code definitions in Terraform, simplifying the process of provisioning resources. Let's examine the HPC Slurm example blueprint. This blueprint has a name at the top along with various variables. One of these is the project ID that we need to specify. It will provision networking for us, incorporate an N2 machine-based debug node set, a compute node set and partition, and an H3 node set and partition. If we search for a machine type in this file, we can see the types of machines we have for our debug, H3, and login nodes. Let's check the Google Cloud documentation to learn more about H3 machines. The H3 Standard 88 are high-performance CPU machines with 88 CPU cores, 352 gigabytes of memory each, and they utilize high-performance processors. To understand costs, let's check the VM instance pricing page for the H3 type node. In the US Central Region, each machine costs about $5 per hour. Considering that the node count is dynamic and capped at 20, deploying H3 nodes can become quite expensive. We might want to modify our blueprint if we prefer something more budget-friendly. Now, let's run the gcluster create command to generate the Terraform setup. We'll supply our project ID, which was left blank in the blueprint. Everything else remains at the default settings. We encountered an error. We need to enable one more API, the Service Networking API. After enabling it, let's retry creating our Terraform setup. This time, the creation succeeds. Now, let's deploy it. In the HPC Slurm folder, we can inspect the automatically generated Terraform folders and files. All that's left is to deploy Terraform with the gcluster deploy command. We're prompted to either apply the proposed changes, view them, or cancel. We're safe to apply these resources, so let's proceed and monitor the resource creation in the logs. We're receiving an error related to cloud service networking, which is interestingly tied to the API we just enabled. Let's try deploying again to see if the error persists. As we get past the private VPC connection, it does seem like we just needed to wait a bit for the service networking setup to finalize backend operations. Now our Terraform plan is looking good and proceeding as expected. As Terraform runs, we can check out the resources being created in the Google Cloud Console. On our Compute Engine page, we can see that we have a controller VM and a login VM. We can also review the Filestore service where we can see a new NFS shared system and US Central 1A being spun up. This is being provisioned via this cluster toolkit blueprint and therefore via Terraform infrastructure as code provisioning. Once the cluster has been fully created, we receive some instructions for destroying the infrastructure. Overall, this is straightforward. We just need to use the gcluster destroy command. If we scroll up, we see other resources that were deployed, such as cloud storage buckets and our now healthy file store instance. Note that our H3 node set is going to be more dynamically deployed. Our file store instance is not cost negligible and is always running. It offers a terabyte of total storage. By checking pricing details, we can easily calculate its cost at about 27 cents per hour. Let's also check out our cloud storage bucket, which contains our Slurm files, including node set configs, partition configs, and important scripts. With our deployment completed, we can now connect to our login node via Compute Engine and use the browser SSH feature. It provides a convenient way to access this instance. Running a simple Slurm command as an example, let's try the hostname command across 3 compute nodes. These compute nodes will be dynamically created when we submit the job. Let's refresh our Compute Engine page and you can see these debug nodes coming up. If we look at debug node 0 to see more details, we can confirm it's the N2 standard 2 machine that we expected based on the blueprint. In just a few minutes, we get the results back. Most of that time is used up by compute provisioning since the hostname command itself is incredibly quick to run. We're now successfully running jobs across our Slurm cluster. We want to ensure we clean up our cluster as well, which can be done using the gcluster destroy command. Our dynamically provisioned capacity should automatically go away if left idle for more than about 60 seconds. After refreshing the Compute Engine page a few times, you'll see that the dynamically provisioned capacity goes away. Let's complete the process by running the destroy command to remove all the remaining infrastructure. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include the diagram file in the description as well. If you have any questions, please post them in the comment section and we'll do our best to respond. Thank you very much for watching till the end, and please enjoy responsibly.